Dear attendees, among all the reactions, we can distinguish chemical reactions, reaction rods, reaction underworld, diehards, and also React.js and ReactPHP. Now, let's talk about the latter. You probably already know it. ReactPHP is a low-level library for event-driven programming in PHP. Frank Berger, standing in front of you, will show how to build a simple chat client with real live coding in vanilla JavaScript and ReactPHP as a server, and explain the basic concepts behind the process, how to communicate through Websockets, and the possibilities of deploying it on a web server. Frank, I give you the floor.
Well, thank you. I think that covers the talk. Maybe.
Hold on a second.
No?
I guess it's still off. Yep.
Okay, I turned off my microphone, sorry. That covers the talk. I think we can go for early beer. No, let's do some stuff here. Small reminder, it's not really live coding, but it's stepping through code. I tried it with live coding. It got a bit confusing, so I changed it to showing the code and stepping through it. But I will really describe the code which will run and which we'll see. So welcome to Introduction to ReactPHP and WebSockets version 2.0. Short stint about me. My name is Frank Berger. I'm head of engineering at a small web agency called bfactor in Stuttgart, Germany. I started as a Unix system administrator in 1996, a long time ago, and doing exclusively web development since like 2000. I'm active in the Typo3 community as a maintainer for several extensions, but obviously I do other stuff as well, otherwise I couldn't talk about ReactPHP and WebSockets. The goal of this talk is that basically you don't need large frameworks, even on the back end, on the PHP side, and you don't need large frameworks on the front end to do stuff like this, to do even amazing stuff like this. We have so many large frameworks in JavaScript, which are a whole universe in itself. So this is the goal, to have it, to show that it's possible in a simple way. So, WebSockets. Bit of trivia. The protocol they are using is WS or WSS if it's a secure socket layer. Standardized in 2011 and is located on the level 7 of the OSI model on top of layer 4 TCP. I say that because when I talk to Unix people, to C programmers, they have a very different perception of what a socket is. It's a very low-level thing, a POSIX system-level thing. WebSockets are an upgrade protocol to HTTP, so it runs on top of HTTP with some extra headers to force the browser into this bidirectional communication with the server. As I said, it allows full duplex communication. The server can send indiscriminately messages to its subscribers, and the browsers can send messages directly to the server, which then can be handled as you see fit. Support in all major browsers these days. I mean, 2011 is a bit is an old protocol, so it should be supported in all browsers now, and support in all major languages that are out there. ReactPHP and Ratchet. I wrote the userland solution in PHP. It is a userland solution in PHP. There is Framework X as well, but they don't have a direct WebSocket implementation, so that's why I'm using ReactPHP with Ratchet. Userland means it does not need any extra PHP extensions. You can use any vanilla, normal PHP binary to run this stuff. There are PHP extensions which can do similar things. non-blocking IO-driven stuff like that. Even with WebSockets, if that's your thing, a more concise thing, then you can use that as well. I'm more for the userland thing. You remember, simple, not many frameworks. That's my goal. ReactPHP. As said, ReactPHP is an event-driven, non-blocking I/O framework in PHP. Think Node.js on the server, but with PHP. A lot of PHP, but it's a PHP conference, right? Runs on a separate port on the server, needs to be proxied through the web server. You don't want to run this directly on port 80 or port 443. You usually have a terminating web server in front of it, which does the SSL as well. It can handle thousands of connections and events in a single PHP process. I mean, really thousands. I had this in production, or I have this in production, and there have been over 8 to 1,000 users using that small single PHP process, and they did a lot of communication with it. So this is really enterprise scalable. Doesn't need any special extension in PHP, but it leverages the new features like fibers from PHP 8.1 on. Ratchet is a WebSocket implementation on top of ReactPHP, which you can use. It's an abstraction. They have a RFC implementation of WebSockets as well. If you don't want to use Ratchet directly, it's just a nice, concise tool to use for this purpose here. That's a basic implementation for the server side. I'm going to code now. Composer require the Ratchet. We're going to use the Echo server. I made a new Ratchet application. Host name here is usually the host name that is used with which the browser connects the web server, or the WSS part. If you have connection problems, if it doesn't work, it's usually located here in the hostname part. Maybe you still have your local host in it, or 127.0.0.1, stuff like that. That's usually the problem when you can't connect to the WebSocket server when you put it in production. Then we add a route. That's the standard Symfony router here. And we add the stock Ratchet Echo server. And we allow post, get, any option. And then we run it. On the client side, it's a small HTML page. I have a button that says send message, and I have an unordered list with the ID log where I'm gonna put my stuff in, which comes back from my WebSocket server. And this is the JavaScript part. I go through it as well. I made my connection. You see again the host name. For my example here, I'm not on SSL, so it's just WS. Host name, port, I'm going to connect directly in this case, and my route is /echo. Then I add an open event, and once the connection is open, this event fires when the browser is able to successfully connect to the WebSocket server and has a session, basically. Once that is done, I'm just going to send a hello to the web server, to the WebSocket server. Sorry. When I get back, that's on message here. I create an event when I get a message event in. The server sends something to me, to the browser. I create an LE element, a new one, add whatever data is in that event, and append that LE to the log. And last but not least, I have the button. I add a click event handler, rather standard. Check if I have a connection and the connection is ready. You shouldn't try to do anything with the connection object if it's not ready, if it's not really connected. You will get weird results, basically. And create a new date, and I send another message, a fixed message with the button, hello Poland, welcome to step 1. That's it. That's all we're gonna do. let's try to here see some echo. So I'm gonna step 1 PHP wrong platform here. Oh no, don't worry, it's not a problem. I have HDBug on my local machine. It's a development machine, so I have HDBug in my PHPs, in all of them, in all binaries I have installed. And what happens is Ratchet warns me that I shouldn't have HDBug on if I want to go to production. But that's all, and I do it with a stack trace. So nothing bad happened. It runs. And I have here my step 1 HTML. This is the send message. And I reloaded, and you remember when I connect to the WebSocket server, I send a hello. The hello comes back. It's just echoing it back. And when I press the button, I send the message. It sends it back. Send the message, sends it back. And you see on the timestamp, it just runs, just goes on and on. Right. A short overview over the events again. I wrote here client side, but the terminology is the same on the server side. We are talking with the same verbs, open, message, and so on. So you have the on-open message, the on-open event, the on-message event. There's an on-close event when the server disconnects the connection, which is possible. And there's an error event when something went wrong, like wrong host name, doesn't work, internet fault, network gone, stuff like that. There is the ready state parameter, which is 1 or true. You can check it for true if the connection is on. And then I have the send method with which I can send strings. We only send strings there. Manage the open state. Always check if the state is open. Stop your JavaScript application if it's not open or if it closes, so it won't crash. And when I really create an application with it, I use custom JavaScript events. So I have different kind of messages. So in my on-message event is just a switch basically, which checks which kind of message has been sent. And then I throw a new JavaScript event, which then can be called by any other part in my application, in my JavaScript application. It even works with React.js if you want to do that. That way, your React.js can then just catch that event. This way, you can decouple all that stuff a bit, and it will still work if you have only small parts in it. Nothing much happening yet. Why don't we try this in 2 browsers? Okay, I have here, I'm going to here do step 1 again. And here's step 1 as well. In 2 browsers, okay. Well, that's not very impressive, is it? Well, it is just an echo server. It just brings back, it just sends the message back to whoever sent it, or which browser ever sent it. What we need to do now is create our own handler, our own implementation, and distribute that message to the other browsers, to any browser that is connected, basically. So, back to the coding. I create a new class. I call it myChat, and it has to be the message component interface, implementing the message component interface. I'll add a object storage type for clients, for my clients. This is where I will store the connection that comes in, so I can iterate over it. Constructor just creates the object storage. You see, I'm old school. I don't have all that PHP 8.3 and 8.4 yet, constructor yet to learn. Okay, on open, when a browser connects or a client connects, I'll just attach that connection to the client list. That's all I do. That's all that is necessary in this point. And when a message comes in, the browser sends a message. I'm gonna iterate over all the clients and just send each client a message back, the same message back. Echo. Message in, message out, same way. I'll just send it to everybody. To finish up, on close, if a client disconnects, I'll remove that connection from my clients list. And on an error, I just close the connection that came in. On the server side as well, I create a new route. I call it chat. Add my chat class, an instance of my chat class I just created. And on the client side, I just changed the path, the routing. Let's try that. Okay, step 2. I'm gonna change here to step 2 as well. Hello. Nice to meet you. Hello, hello. Yeah, hello. That's more like it. That's more something we want to do. That's more something we do where we can talk about communication between browsers, between clients. Cool. Now that we have the foundation, we can distribute messages. We can have clients connect. Let's implement a simple chat. How about that? On the client side, the HTML part, I'll change it a bit. I have my chat, my URL, my unordered list. I have a form. I don't need an action. You will see why. And it has an input, a text field for the input, for the message, and it has a submit button. Okay? Chat, form. On the client side, the JavaScript part, I'll connect to still to chat. I don't change the routing now. And I have a global variable, yeah, Sumi, global variable, I know. I have a global variable which I call nickname. And once the connection is open, I'll use the prompt to ask for a nickname to the user who is using the browser. Once I have the nickname, I send a payload which says action, which is then a JSON string later, which says action is login, and I'm logging it in with my nickname. That's the first thing that happens once the nickname has been entered. Then I stringify this into a JSON string and send it to the server, to the WebSocket server. When a message comes in from the server, I pass the payload, whatever comes in, and I create an LE element. I don't need it anyway. I'm gonna switch over the payload action. You see where it's going. We're sending back and forth basically the same messages. And in case of a login, I add the class system to my LE, to my list element, and add an inner text, hey, nickname has logged in. That's all. I add the class so I can format it differently a bit with CSS. In case of logoff, it's a system class system again. The payload nickname has logged out. Bye-bye. And if it's a message, if really a message has been sent, we'll add a class message to the LE. We create a span for the nickname, add the nickname to the span. We create another span, have the message in that span, and append the message as well to the LE. And additionally, if the payload nickname is equal to my nickname, so if I send that message, I will add a as well. A class me to the LE, so I can distinguish between other people's messages and my message. Not so much that, right? Okay, then I get my chat log. I call it chat log. The unordered list. Append the LE I just created and filled, and no, this chat log scroll top chat log last element child offset top is the fastest way I found, the fastest and most reliable way in all browsers to just scroll the page to the bottom, always. Okay, the form we created. We add an event listener submit, throw away everything it would do by default, create a payload, give it the action message, and the message is the content of whatever my message field is, and I add my nickname to the payload, send the payload to the WebSocket server, and have and clear the message field, so I can send the next message. That's why we don't have an action or anything. Right, server side. A lot of code, I know, but you will be rewarded. My chat, same thing. Clients, same thing as before. On open, same thing. We attach the connection. That's the standard way here. Okay, on message, when a message comes in. This part is a lesson from, I gave that talk before, this is a lesson from previous times where I showed this talk, I gave this talk, because somebody managed to hack the thing in under 2 minutes from their iPhone. I find that very impressive, that's why I say it, that people can do it through their phone. Okay, what I do is I go over the payload, strip tags, HTML entities all around, and put it back together. And then I just encode it again because I will use that encoded string anyway. Then I go over the payload action again. This is a server side. In case of a login, I will go over the clients. That's too fast. I will go over all connected clients, and if the client is not the browser or the client that sent the current message, I will just send the message back as it is to all other clients basically. And for me, for my client, if I send this message, it's login. I will attach to clients to the object the nickname as metadata. So I know this connection is that person. The thing is, you always have to think about if the browser reloads or if the connection fails, it is a different connection after that. It's not a real session ID which is persistent through the whole life cycle of how the browser is communicating. It can change. So you are responsible for session management on the server side, if that's necessary, if that's what you need. If I reload, this connection object is a different connection object. Anyway, I add my nickname as metadata. Nice feature of the SPL object storage. I can add as much metadata to an object as I like. In case of a message, I'll just send it back to everybody. Any client, send message. I don't care if I was a sender or anybody else. When a connection is closed, somebody logs off or reloads the browser, which is a close as well. I get the information, the meta information I saved earlier in the login phase from the client for this connection, detach the connection from the client, so I throw it out. And if I have a valid metadata and there's a nickname in it, I will go through all other clients and send them the log-off message. So like log-off, Frankie logged off. Right. On error, same thing again. Nope. Let's try this. Yep. Step 3. .html. There's my thingy. Okay. Nickname Frankie on the left. And Frankie on the right. Frankie on the right logged in. Frankie on the left logged in. Hey, that's nice of them. Hi, welcome. I should learn to type, I know. I'm a programmer. It should be in my livelihood. Welcome to PHPConPL24. Yeah! You too. So, you see, that's the effect of the me message type. If this one, friend on the left, send this. So it's on the right side, the receiving end has it on the left side. So a little bit like a messenger thingy. More stuff to say. Okay, and if I reload here, then you see on the left side, Frankie on the right logged out. Okay? Great. Thank you for the talk. Have a nice evening. Now, I would have loved to everybody connect to my computer. It usually doesn't work very well, so I put it on my server, and you can just try and chat now. Go ahead. I'm going to switch the screen, but the QR code will be there again, here. I'm a cool hacker, that doesn't cut it. You have to do stuff. Yeah, that's better. A bit encoding. Come on, it's JavaScript. Give me a JavaScript through the iPhone. Yeah, it's UTF-8, so you can add emojis. So you see, this is I added a bit more CSS, but it is the same thing on the server side. Great. Zonk. Drop table users, there is no users. Is it true that you named your child drop table users? Yeah, a little droppy. Okay, people, yeah. Oh, you can still chat. I'm going to continue, right? Okay, what about persistence? Maybe I want a log of the chat. Maybe I want to have like a group chat where people can see what happened in the last half an hour, stuff like that. Right now, everything, that's just memory. If we reload the browser, everything is gone. If you restart the server, any connection is gone. There is no persistence here. There's all the messages is there. You saw the server doesn't even do anything with the message except passing out JavaScript. How could we add a backlog? Some considerations here. I mean, this is a fast I/O situation. We need something non-blocking. Or something really fast to store stuff like that. Usually an SQL database doesn't hack it, really. There could be too much interference. It could be slow, the insert. We would like to have atomic updates. I don't want to read a whole structure, add something to it, and put the structure somewhere back. And we need the possibility to retrieve it as a list or a stack. You don't want all the 1,000 messages that happened in the last hour. You just want like the last 50 or something. So we don't use Redis lists. Redis has many different data types in there. It's not just a key value store. There are data types like lists, like queues, like sub-subscribers. It's a very versatile tool, and list is one of this. It's a first in, first out list, or last in, last out, last in, first out. No. List container, and that's pretty ideal for us to use in that case. How can we do that? I'm using pRedis. I use pRedis because they have a fairly complete vocabulary for Redis, even the exotic stuff baked in there. Other clients don't really have that. It's a bit unwieldy to work with, but it's better than writing plain Redis commands. Okay. Same thing as earlier. I have my clients in an SPL storage, object storage. I will have a Redis client, and I have a string Redis connect. Why I extracted here, I will show. And I just do a construct. I can give a Redis connect string, or I will use my default string, save it in the Redis connect. Clients is the SPL storage, and I open the connection to Redis. I built a little helper function so I can ensure that the Redis connection is still open, or it will be reopened. That's why I store the connection string. This is easily done with the ping. You send a ping with a keyword to Redis, and it will answer you with the same keyword. It's fast. It's not really non-blocking. This way we can check if Redis is there, and if not, it will connect it again. Of course, in a production environment, you should add some fault tolerance, some double checking, of course. Okay, on open is the same. That's why I skipped it. When I get a message, I do the Redis connect Redis to ensure that my Redis is there. And in case of login, when somebody logs in, that's the interesting part. That person will want to have the history, like the last 50 parts of the chat log, and that's what I do here. I will ask Redis for an L range, list range of my key chat log for the last 50 messages or entries. Then I have to reverse it because for my purpose it's in the wrong order, and send it to the person who which logged in. I just sent each message. I did this way here because I didn't want to change the client. In production, when I used that, I changed the client so it can accept arrays, an array with messages. For this purpose here, it was easier to just send the messages. This is not really optimal because it's a lot of sending. You would want to minimize the payloads that are sent and the amount that is sent, or how often you're going to send it. It would be better to just have one send, but yeah. You have me here to explain you why I did it. Okay, and on message, if it's a message, if it was a message I was sent, I'll just push back the message into the chat log. That's one operation as well. It's atomic. It's really fast, so we can accept it that it's done inside of this loop. If it would be more effort to do that, it would have to be like a promise, and I have to do a single wait or something like that. And then I will distribute the message to all my clients. Right. Okay, that's basically all that needs to be done. I'm going to show that. Step 4. Did I make a step 4? Yeah, I did for completion. Step 4. Again, Frankie on the right. And you see, there's already messages there. Frankie left. Hi again. How are things? And if I reload here, I will get all my messages back. So this is the proof that in my Redis there were already some messages. You even said it here. If you can read this, then you are reading a message there from the past when Friendly set up the talk, like last night. I didn't send any timestamps, otherwise you would see that was last night. Right. This is an option to add a backlog. This is something I actually did in production, and it worked really well. Some further considerations. Keep your messages small. Be chatty versus size. I said, well, in my example, I was very chatty. The size would have been negligible with the 50 messages. That would be okay. But you don't want to send large amount of data through a WebSocket. It's designed for small messages, for small commands, stuff like that. If you need to send an image, you can send the link to the image. It will work. It's a browser. It will display images. If it's another client, they can handle the image somehow, the link to the image. And same for any other large data, basically. Use the React event loop to async await. If you do other stuff, if you need to talk to a PubSub subscriber in Redis or to the database for some reason to get session or user information or stuff like that, you would add it to the ReactPHP event loop as a non-blocking stream or something like that and do it with async await. Especially for file system and socket operations, use React Stream. Then you can do downloads as well from the internet or whatever you want and you need to do. File system, even if it's fast, even if you think it's fast, it can be blocking, it can be cumbersome to work with, especially if you need to write. Redis has a ReactPHP event handler as well, a ready-made event handler for ReactPHP where you can add queues, PubSub queues, like RabbitMQ, stuff like that, to send events into the React server. This is the way if you want, for example, the possibility that a admin console or a web page or something like that needs to send something into the chat or into the WebSocket application. This would be the way to have a queue in Redis or in RabbitMQ and have it added as an event handler. You can access all that stuff. It's all one program running in memory. You have access to to the features to send messages to any kind of subscribers. Setting up the event loop manually. If you want to add different parts of ReactPHP to the event loop, Ratchet sets up the event loop for you. If you want to have a separate event loop, you would do it outside of your setup of Ratchet. And no, I didn't highlight it. And you would just create the loop, add your event handler to the loop that you want to use, and you give the loop as the fourth parameter to the Ratchet app. The third parameter is the binding IP address. I would either 127.0.0.1 or 0.0.0.0. If I don't really care who on the server connects it to it. And then I add my routes. Right. Or do manually what the Ratchet app is doing. It's not that large. And then you can add Ratchet itself as a simple event handler on the loop. If you have a already done or already working ReactPHP app, you wouldn't want to rewrite it so it's inside of Ratchet. You would want to just have the Ratchet event loop handler added to it. proxy it. You have to, when it's on a web server, you don't want browsers directly talk to it, like I did in my examples, of course. The best way is through Nginx. Create a upstream service. You can even add more than one upstream server to it. And it will do round robin. You can even do IP pinning in that part. It's fast to set up and proxy add a location in your SSL part and just proxy it up. It's the connection upgrade and upgrade HTTP upgrade are the headers that have to be set when the browser wants to create a WebSocket connection. Apache is easier. You just it knows what it will determine from the WS or WSS that you're talking about WebSockets, and will do all that stuff for you. Problem is Apache has an upper limit for connections, and you will run out pretty fast. So I would rather do it on an Nginx server. Keep it running. You need to, it's a PHP process. It's PHP server.php or whatever it is. You need to keep it running on the server. Forever is a tool from the Node.js world. It's a bit ironic. I get rid of all the Node.js, and now I'm using a Node.js tool to have my PHP server running. But it works really well. You can register several tools, several services which need to run. You can define failovers, failover handling. You can try retries when server fails and you want to restart it, how often you want to restart it. It's actually pretty good. It's sad that it's a whole Node.js thing, but it works. You can use Docker, running the server PHP as an entry point, and mark the Docker container as restart when it fails. On Linux, did that as well. Register it as a systemd service. It's not that hard. You can then you can set there as well that a fail on restart on fail. Or what I did, I run it inside a screen session. It is really stable. If there are no bugs or no race conditions in there, it will run. That server you just saw, it ran like for a year. It just runs. These are some real-life examples where I used this. This was during the pandemic. Our customer had basically organizes for their interest groups several conferences each year, and they moved it to online, but wanted to have their own platform for it. So we had a group chat here on the right side, where everybody who was logged into the conference could use the group chat in this cafe, basically, and there were several tables, and when you were able to see who is sitting on the table, and sitting on the table means that you would have been thrown into a big blue button conference session, so you can talk through webcam with the people, and if somebody got out, the seat would be free here. That's all communicated real time with WebSockets. That's where as well came in that I had to blue button talk to the WebSocket server through a webhook, through Redis. So it is a thing that really works. That's really stable. Once it's set up, it's really stable. That was a really interesting project. And in the same thing, there were one-to-one chats. Basically, I created they had two IDs. Each user had an ID, and I sorted the ID like that. The smaller one is always in front, and my key was basically for the list was user 1 ID, user 2 ID, and then you could have a one-to-one chat with multiple people. And there were like almost 1,000 people online during that time. Of course, this wasn't in one server. This was we distributed onto the cloud, but it still worked very nicely. This is a mature framework where you can really do production stuff in. One caveat, sadly, Ratchet is looking for contributors and maintainers. They have new maintainers, but they are evaluating right now how to continue with the project. It is not compatible with all the latest ReactPHP version, but if you focus on if you want to do WebSockets, you don't really have a problem with that. There are several, most event loop handlers and so on will be available to different versions for ReactPHP, and you can still work with it. It's just not the latest version. It will still use fibers. It will still be working on the PHP 8.3 in the newer versions. It's just not the latest thing. They are thinking about as well to have Ratchet not as an application on top of ReactPHP, but as a middleware, which would be a nice idea, because right now the middleware, like if you have a web server done in ReactPHP, the web server part is a middleware part. And therefore it would be natural to have the WebSocket server as well, a middleware part inside the ReactPHP loop. We will see where that goes. If you want to contribute, you're very much welcome. Summary. Working with WebSockets, not so hard. And you don't need large frameworks to start or to finish. It's easily learnable. It's not that much, and you can go forward with your project. Your project can grow with your knowledge about it. You don't need large JavaScript frameworks with that, but you can use them if you like. It's all standardized. So go ahead, build something cool in interactive applications. What are your questions? Fastball.
Tuk-tuk. Okay. So I wonder if there is another way of authentication for WebSockets than just plain session global variable. Is there any special way for authentication? Sorry.
I would do it that way, that you do it. You usually have the authentication on the web server side anyway first. You have like a framework where you let your users log in. Mm-hmm. So you have something like a session already. You could manage that session in Redis again and have the WebSocket part read the session, and you would just give the session key. Right. In the connection phase. That's something I did in that project I told, because they were moving between pages, so there was always a reconnect all the time. Yeah. But I needed that person in the WebSocket server stable, so I built a session system inside of Redis, which the web server wrote into and canceled, and I could check really fast when a message came in, if that user is still connected.
So nothing special, just use the regular one.
Yeah.
Okay.
You want something fast. If you overdo it with other stuff, encryption or something like that, that's not the way to do it. You would want to do it before, basically.
Okay.
As I said, checking in Redis, it's a real fast action, and it's about real fast atomic action. If a key is there, you will get an instant message. If the key is not there, throw it away.
Right.
Do it like hacksaw.
All right. Thanks.
Welcome.
What are the limits on the one message on WebSockets? Can we post images, for example, via it, or it's only for texts?
Well, you could upload a base64 encoded image and have it, of course. But the thing is, this in this run loop, you want to have the single action is like a tick in that loop, and you want to have it really fast. If you want to upload images, there is already a ready-made facility to upload images in web servers and web applications. Use that. And then give the information to the WebSocket server, hey, there has been an image uploaded through Redis communication. I come back to the Redis because it's an integral part here for the communication from the outside world into your ReactPHP application. I wouldn't reinvent uploads, basically, in that part. Symfony does it much better than me.
How about long-term running stability of this solution? As all we know already, that PHP wasn't designed initially to have long life living processes. How about, for example, memory leaks and so on?
Basically, it runs really well, and it runs really long. You have to be mindful of your memory, of course. You come into that all that memory management problem, like you have with Go, like you have with Python. If you accumulate a lot of memory and don't have a plan to clean it up, then you will run out of memory at some point. So that's a consideration. That's as well a plus point of the SPL object storage. It does the cleanup really well. If you detach an object there, the memory will be free. But otherwise, if there is no race condition inside that run loop, inside that process, it will run for years. PHP doesn't care about that anymore. It's not like in older versions of PHP, like PHP 5 or PHP 4, or even sometimes probably PHP 7, it had problems internally that it will stop at some point if you have a really long-running process. In PHP 8, even with later PHP 7 versions, it will run for years. If nothing else happens, if the server doesn't crash, disk full, memory full, it will run really long.
Okay, thanks.
Anybody else? Well? No. Doch. Yep. That's the where you can rate the talk and stuff like that. I put the links to the slide into that platform. I can't remember what it's called right now, where the talks are managed, where you can rate the talks. There's as well a link to the GitHub, so you can check out that code I just showed you and play with it. Take it as a learning experience. Just start there. Thank you.